Alright, this is the last video on energy, and actually the last video of our unit. We got a test coming up soon. So, conservation of energy, we're just going to apply those ideas to a couple other ways, a couple other types of problems you might. The first thing is sometimes you might not be given mass. Hopefully you remember from our skateboarding worksheet that if you notice, the front velocities were the same as the back velocities. So even though you went from being 65 kilograms of mass to 120 kilograms of mass, the change in mass had no effect on the velocity. You can use this if you're working with, say, like dropping a ball from 30 meters high, which is going to be the top, and then you want to know, say, velocity just as it hits the ground. So that's going to be the bottom. All right, so we've learned before that your potential energy at the top is equal to your kinetic energy at the bottom, okay? And that's because at the top your velocity is zero. So you have no KE. And then at the bottom, height is zero, so there's no PE. All right, so what you can actually do is you can write mgh equals 1/2 mv squared. Now you'll see there's a mass on both sides. If, say, I wanted to kind of rearrange things and I needed to find, say, velocity, I'd need to move mass over. If I divide this side by mass, I also have to divide the other side by mass, so the masses cancel out. Okay? So you're going to have GH equals 1/2 V squared, and then if you want to get that down to being V, we're going to have 2GH equals V squared, and then to get rid of the square, you take the square root. So V is equal to the square root of 2GH. The key thing here, the reason why mass doesn't affect velocity is because the masses cancel out. Okay? So let's continue this. We know that height is 30 meters. We know G is 10, because that's always true. And we want to know V. So we can use this equation. It has everything we need. So V is equal to the square root of 2 times 10 times 30, which is going to be, let's see, 200 times, 20 times 30, which is going to be the square root of 600, which ends up giving you 24.5 meters per second. All right? So if you're working with, say you're given the height and you want to find the velocity at the bottom, you can set GH equal to 1/2 V squared. You can also do this, say you're given the velocity, you want to know how high you get. You don't need the mass to figure that out. All right? One thing to be really important, if you need to find an energy is dependent on mass. All right? The only time this works is if you're finding velocity or height. If you're solving for energy, you're going to have your masses. And we saw that in that skating worksheet too. Okay? The energies for the 65 kilogram were less than the energies for the 120 kilogram skater. The only thing that didn't change were the velocities and the heights. Okay? So another type of thing, and we haven't really dealt with this yet, is you don't have to start with potential energy at the top. You could start by having the velocity at the bottom. Or there's even, if you're throwing something up in the air, the same rules still apply, because the only thing that's keeping that object moving or trying to slow it down is gravity. Okay, so let's apply these energy things to throwing something up into the air. So we have a 3 kilogram ball, so we know mass is 3 kilograms, okay? And when it leaves your hand, so if we're talking about a ball, leaving your hand is going to be 0 meters. That's the very bottom. You have a speed of 9 meters per second. Remember, speed is just velocity without direction. So we know our velocity is 9 meters per second. So what's the kinetic energy? Well, Ke equals 1/2 mv squared. All right, so 1/2 times 3 times 9 squared, which is going to be 1.5 times 81, or Ke equals 121.5. And remember, energy's units are joules. Okay? So this is our Ke at the bottom. Let's remember that. So we just figured out Ke, 121.5. And again, we're still referring to at the very, very bottom. Potential energy at the bottom. Our height is 0 meters. If you plug in 0 into your MGH, anything times 0 is 0. Okay, so our PE equals 0 joules. ME is always Ke plus PE. So that's going to be 121.5 plus 0. So 121.5 joules. All right. Now we throw the 3 kilogram ball in the air. We know our Ke, we know our Me. Then we want to know the maximum height. Okay, so that's the highest it can go. That's going to be at the top. So if you remember, at the top, Me is equal to PE at the top, because at the top your velocity equals 0, so you have no Ke. So that means at the top our potential energy is 121.5 joules. Our mass is 3 kilograms. All right, G is still going to be 10, so that never changes. And our equation, so here's our knowns, our equation is going to be solving for height. That's going to be PE over mg, which is going to be 121.5 over 3 times 10, or divided by 30, and you end up getting 4.05, and that's going to be meters. Okay? You don't always have to start with the potential energy at the top. You could also start with the kinetic energy at the bottom and then work your way backwards compared to what we've been doing before. So, I think at this point we've hit just about any sort of problem you might see. The key things are your mechanical energy is conserved. All right. Me equals PE plus Ke. And then you just got to remember at the top, your velocity equals 0, so no Ke. Then at the bottom, your height equals 0, so there's no PE. And then I'd say the only other main all-encompassing thing is the fact that mass affects energy, but not your velocity or your height. Okay? These are the huge main things where if you understand how to apply this information, you should never have an issue with an energy problem. But if any one of these components doesn't make sense to you, you need to ask questions and figure out why it doesn't make sense. Because if you could sit there and know all of this information, there shouldn't be an energy problem that should confuse you at all. You just have to figure out which part is the most useful to you at that point in time. So I will see you guys in class tomorrow. Don't forget to do the assignment.